Hello everyone, my name is Jacques Lutia. Today I am here again to continue explaining about the singular numerical relativity, which is the completion of general relativity. Last time I said that numbers are the best tool for us to study the black holes. Therefore, today I will explain about the structure and the properties of numbers. I said already that numbers are the bits of space and time. When we say bit, meaning numbers serve as a tool of measurement of space and time. Therefore, numbers are flexible. Just like space and time can bend, numbers also can bend. Numbers can be stretched. For this reason, the singular numerical relativity says that the value of a number depends on its location. When I say location, here I'm not referring to a physical place that you know or you can touch. Here I am referring to the levels of variability installed within the structure of a number. So what are these levels of variability? In order for you to understand what the levels of variability are about, I will bring you back to your first day in school. When you went for the first time to school, the teacher wanted to introduce mathematics to you, and probably he must have told you to bring some objects for counting. So right now I have with me 5 books here. As you see them in color here, these are the books. Then let's count them as we did with the teacher on our first day in school. 1 book, 2 books, 3 books, 4 books, 5 books. This is all we did. However, we failed to notice something. Look very well. Every time I have been moving only 1 book, and to each book I gave a value. The value is changing as I was going on counting. So the first book is only 1 book. We say 1 because there is no book ahead of it. When it comes to the second book, we say 2 books. Why 2? Because of the first book that went ahead of it. We go to number 3, we say 3 books because of the 2 books, meaning book 1 and book 2 that went ahead of it. For number 4, we say 4 books because of the book number 1, 2, and 3, which went ahead of it. For the fifth book, we say 5. Why? Because of 1, 2, 3, 4, which went ahead of this fifth book. So what were we doing while counting? When we count objects, we consider the whole batch of objects as a group here, a group of 5. Then we are cutting or slicing the 5 into pieces of 1, pieces of 2, pieces of 3, pieces of 4, pieces of 5. So what does it mean? That if I have a piece of 5, I can make a group of 1 out of this 5, a group of 2, a group of 3, a group of 4, and a group of 5. So 1, 2, 3, 4, 5 here are the degrees of freedom. So number 5 gives me the freedom to be 1, to be 2, to be 3, to be 4, or 5. As a matter of fact, we have our country, for example, that must be represented by a team of players in the Olympic Games. And our country may have maybe 100 million people. But during the games, we need only one person to represent the whole country. So the victory of that person will go to the whole country. So as you see, 5 can be represented by 1, by 2, by 3, by 4, or by 5 itself. That's why we call them degrees of freedom. But in our theory here, we call them levels of variability. These are the levels of variability, meaning number 5 can take all these values. He can play his role using all these values. That's why we say the value of a number depends on its location. And for you to understand better these values, I would like to take you to NASA. Let's go to NASA. Because at NASA, we launch space rockets. And then there, the operator will be counting. He will say 10, 9, 8, 7. What do we see? We start with a piece of time, which is 10. Then, as soon as we say 10, the piece of 10 is gone. What remains is only a piece of 9. When I say 9, the piece of 9 is gone. What remains is a slice or a piece of 8. So my chances are reducing every time I say one number, I pronounce one number, already the piece related to that number is already gone. So here, 1, 2, 3, 4, 5 are my pieces of time I have. But in the case of NASA, of course, we start with 10. So up to number 10. So when it's reducing, my slice of time is being reduced. And those are the degrees of freedom, or the levels of variability.